All right, so this is a type 1 question. Okay, we know that we have 250 grams. That's M, 250 grams. Okay, and we know that it's water. So big M, H2O, so that'll be 1.01 times 2 plus 16, or 18.02 grams per mole. Okay, for a molar mass, and we are looking for N, as we said, type 1 question. All right, so very little to do here. N equals little m divided by big M, okay, and we are looking at 250 grams, okay, divided by 18.02. Incidentally, 250 grams of water is how much? It's another word for that measurement. 1 cup. Okay, 250 grams is 250 milliliters when it's water. Okay, and so that is 1 cup of water. All right, so 250 divided by 18.02. In 1 cup of water, there are 13.87 moles. Of water. Okay. How many people have done number 2? Okay, I'll give you guys a little bit more time here. Okay, and then we'll look at number 2. Okay, so number 2 is a type 2 question. Okay, and it tells us that we have 27.25 moles. So they gave me N 27.25 moles, and they told me it's calcium bromide in words, like you'll get it on your unit exam on Thursday. Okay, so big M is calcium with bromine. That's a +2, that's a -1, so we're looking at CaBr2, 40.08 plus 79.9 times 2. Is that 199.98?
Yep.
Don't envy my math skills, I just remember it from period 1. Okay, 199.98. And we are looking for little n. Okay, so we have to do a little manipulating. And we got n equals little m over big M. To solve for little m, I'll have to multiply both sides by big M. Okay, giving me that formula there. So little m will be 199.98 grams per mole.
I think it's 0.88.
88. Okay, see, that's why you shouldn't envy my math skills or my memory. 88. Because neither one of them are very good. Okay, good catch, thank you. And never be afraid to correct me because I make mistakes all the time. Okay. Okay, and that is going to be multiplied by 27.25. And that is moles. So the moles are going to cancel, and I'm going to be left with grams. And so 199.88 times 27.25. 5,446.73. So just about 5.5 kilos, okay, of that stuff. Okay, questions on type 2? Yep. How many people have done 3? Okay, give you like 2 more minutes on 3, then we'll go over that, and I'll give you a little bit more time for 4.
Mr. Codere,
Yep.
I have a question for you.
Okay.
After we get like your molecules and stuff, how do you get like the M thing?
Okay, so once you know your number of molecules, this is where you use Avogadro's number.
Okay.
Right? So this is how many molecules you have. Avogadro's number is how many are in 1 mole. So it goes like this. I have 36 weeks. How many does you divide by?
3.
Right? Because you divide it by the number of the dozen. You divide by the number of the mole. Make sense?
Yeah.
Not in that situation. In a type 3 question. as long as you show that, that's good. I see your manipulation. She's gone for a long time. Okay, let's have a look at number 3. Okay. Oh, geez, I've been recording that whole time. Okay. What type is number 3? It's type 4. Okay. It asks us for mass and gives us the number of molecules. That's a type 4 question. All right. So I've got the number of molecules. 4.5 times 10 to the 25, okay? And they are lithium sulfide molecules. So Li with S is going to be Li2S. So that'll be 6.94 times 2 plus 32.07. All right, so we're looking at 45.95 grams per mole for that one. Okay? Now, we are looking for mass, little m. If I'm going to get little m, I need the number of moles. I have the number of molecules, and I have Avogadro's number, which is the number of molecules in 1 mole. So, what do I do with those two numbers? I divide them. Okay? I have number of molecules. Avogadro's number is molecules per mole. Molecules are going to cancel. Going to be left with moles. Okay, so we are going to have then 4.5 times 10 to the 25 molecules divided by 6.02 times 10 to the 23 molecules per mole. Okay, the molecules will cancel. I'm left with moles. It's going to be a fairly big number, like 70 something. Okay. Remember that, guys, when you enter this into your calculator, anything in scientific notation needs to be enclosed in brackets. If you don't, so that's supposed to be 10 to the 25. Okay, if you don't, your calculator will do order of operations. So for example, okay, if I didn't do this in brackets, the next thing that would happen is it would divide by 6.02. And then it would multiply that by 10 to the 25. This is a totally different answer than dividing by 6.02 times 10 to the 23. Okay, so you have to make sure you enclose everything in brackets. Otherwise, your calculator will do order of operations as it's programmed, and you won't get the right answer. Okay, so numbers in scientific notation must be enclosed in brackets so that your calculator does what you want. Okay, 74.75 moles. Now that I've got n, the number of moles, now I've got to do a little bit of algebra because the mole equation is not set up to calculate m until I multiply both sides by big M. Now I can go 45.95 grams per mole multiplied by 74.75 moles. The moles are going to cancel, and I'm going to be left with grams. Going to be a fairly large number.
Okay, 3434.80. What are my units? Grams. Easy to get lost in a type 4 question, okay, because there's so much to do and switching around of units and everything. So always double check at the end. This question wanted mass. Is my answer in grams? Good. Okay, those are things to always double check. Okay, all right, and I'll put question number 4 up there. If you're not done that one, I'll give you a few more minutes on that one. Okay, so how many molecules of potassium carbonate are in 500 grams? So the question wants number of molecules. Question gives the material, potassium carbonate, K2CO3. Right, so that is going to be 39.10 times 2 plus 12.01 and plus 16 times 3. 39.1 times 2 plus 12.01 plus 48. Okay, 138.21 grams per mole. All right, and the other part of the question, 500 grams of this material. Okay, I know little m and big M, what can I get? N, okay, so that's my next step. Solve for the number of moles. So I will take my 500 grams, I will divide it by 138.21 grams per mole. My grams are going to cancel. 500 divided by 138.21 gives me 30.62 moles. But I'm going to keep all those decimals in my calculator because I'm about to do what? About to find the number of molecules and take that number and do what with it? Multiply it by a gigantic number. Okay, so it's important that I keep all those decimals. They're going to make a rounding difference for me. Okay? All right, so number of molecules, okay, equals 3.62 moles times 6.02 times 10 to the 23 molecules per mole. So when I do that, the moles are going to cancel, and I'm going to be left with molecules. So that number in all its glory with all the decimal places, okay, 6.02 E23, and I get 2.18 times 10 to the 24. Now I can round. That's my final answer. 2.18 times 10 to the 24. And my units are molecules. Okay, is it important to include this part in your answer when you write it down? The times 10 to the 24. It is. You'd be surprised how often on a test someone will leave that as 2.18 molecules. And last time I checked, you can't have 0.18 molecules, and really that's a really small number of molecules anyway. Okay, don't forget to put the exponent, the power of 10, on there because it makes it, well, times 10 to the 24 difference, okay, in your answer. All right, how are we feeling about these? Okay, just got to make sure we know the patterns, right? There's only 4 patterns to know. Okay, if we know those patterns, we can do well. We know there's going to be one of each on the unit exam. Okay. All right, so I've got a few of the wordier ones, okay, that I'd like you guys to work on here. Remainder of class, trying to trick you with some stories, okay. Some of them are just plain Jane, okay, but some of them do have a little bit of tricks in them to, make you think. All right, so those ones that are on the board, and you're done.